This section examines valve trains. The valve train includes all of the components that are driven from the camshaft to the top of the valves. There are different types of valve trains, depending on how many camshafts there are and where they're located. This is an overhead valve or pushrod system. The valves are in the cylinder head, but the camshaft is in the block near the crankshaft. A valve lifter or tappet rides on the cam. As the cam lobe reaches the lifter, it rises and transfers the motion to the pushrod. This then moves a rocker, which in turn pushes the valve open. There are different kinds of lifters. A solid lifter is usually a hollow cast iron cylinder mounted in a bore in the crankcase. It's free to rotate slowly, which distributes wear from the cam over the face of the lifter. The gap between the valve tip and the valve train is called valve clearance or valve lash. This must be maintained when the cam is not applying pressure to open the valve. It can be adjusted with a screw and lock nut built into the rocker arm. These adjustments are needed regularly. Many engines now use hydraulic valve lifters. Their purpose is to make the engine quieter and eliminate the need for valve clearance adjustment. When the engine is operating, oil under pressure from the engine's lubrication system is supplied to the lifter. The oil is assisted by spring tension to maintain zero valve clearance, but through a system of valves, it's trapped in the lifter as the camshaft lifts it. Since oil is not compressible, the lifter acts like a solid lifter. When the valve is closed, any oil lost during the previous lift is replaced, and zero valve clearance is maintained. Rocker arms transfer motion to the valves. The rocker arm rocks up and down. In modern engines, the pushrod system is being replaced by the simpler overhead camshaft arrangement. The overhead camshaft is located in the cylinder head. There can be one or two camshafts. Let's look at a single overhead camshaft arrangement. Single overhead camshafts can use rocker arms. The cam can lift one end of the rocker arm, or it can press down on the rocker arm. On double overhead camshaft systems, the most common arrangement is to use a bucket tappet or lifter. It operates in a guide that protects the valve against side thrusts, which it would receive if the cam operated directly against the valve. The adjustment of valve clearance is usually done by changing accurately machined spacers. Spacers are available in a range of thicknesses, and they're exchanged to obtain the correct clearance. Some overhead cam engines use a hydraulic lash adjuster to reduce lash in the valve train. They have zero clearance at the valve stem, so there's no need for tappet adjustment. It can be put in the valve end of the rocker arm. Like the hydraulic valve lifter, it has a body with plunger held against the valve stem by a spring. Oil supplied to the adjuster keeps the plunger in contact with the valve and eliminates lash. Lash adjusters can be put in the cylinder head at the end of the rocker arm. The lash adjusters are stationary and have a pivot for the end of the rocker arm. The plunger in the adjuster holds the rocker up against the cam. In the lash adjuster inside the bucket tappet, the plunger's hydraulic action holds the bucket body against the cam on the camshaft and also against the tip of the valve stem, so that there is zero clearance.